My name is Sam Ruben. I'm the Chief Sustainability Officer and one of the co-founders of Mighty Buildings.
Welcome back to another episode of the Structural Engineering Podcast, hosted by Zach and Max. If you're interested in what the future of construction will look like, then this is the episode for you. Sam co-founded Mighty Buildings, a 3D printing tech construction company that uses a unique material to prepare complete modular units ready to be dropped in site. I don't want to give away too much, so we're pretty much just going to get right into the episode. I hope you enjoy. So, Sam, Mighty Buildings is this really cool 3D printed system that I learned about fairly recently, and looking at your website, we just had to get you on. For someone that has no idea what Mighty Buildings is, hasn't been on your website or seen you elsewhere, could you just paint us a picture of what is this thing you're building?
Yeah, so Mighty Buildings, we're a Oakland-based construction technology startup that's using 3D printing, robotic automation to address the housing crisis by increasing productivity to allow the existing labor force to build more.
That's perfect. So, something that kind of always rubs me the wrong way is that we have been doing buildings the same exact way for so long.
You get it.
The first, I wrote a little article on this, but the first high-rise steel, almost traditional to what we think of now, was 100 years ago, and we're doing it just the same. The house I live in is 125 years old. You would not know. It's just it's just a wood stick frame house. So that's absurd. When you started Mighty Buildings, what was the most important goal you had in mind with these structures? Is it that the old way of doing it isn't good anymore? Can it be better? What is the key?
Yeah, so with Mighty Buildings, it really came about from the realization that, as you say, we're still building using archaic methods. I mean, you could take someone from a 1900s build site, drop on a site today, they might be using a nail gun instead of a hammer, but they're still using nails, still using rivets. They figure it out in less than an hour. Mm-hmm. And so that really speaks to the fact that, as you say, we're still using these old techniques. And the reality of the situation is, here in California, we need over 2 million homes not to achieve to close the housing affordability gap, but just to get on average to the rest of the country in per capita housing.
Yeah.
And to close the housing gap, we need over 3 million houses. And the simple fact is, we're building maybe 100,000 a year, if that. And so the simple fact is, we're just not building, and the way we currently build does not produce enough units for what we need. And that spoke to us and basically kind of highlighted that we need a better way to build. And so this is something that's impacting, I think studies show it's going to impact 1 in 3 urban dwellers by 2025, so 1.6 billion people globally. And on the business side, that's leaving, the construction industry is leaving $1.6 trillion on the table every year in unrealized revenue because of that lack of efficiency.
How do you categorize the Mighty Building structure? Is it a 3D printed building? Is it a prefab building with 3D printed components? What is this thing?
Our approach is definitely prefab. So we are producing them in our facility. And what we've done is that we've created, whereas a lot of these 3D printing companies that are doing construction are focused on different ways that you can pour concrete forms using unique mortars and everything. But you still have to put in your rebar, you still have to pour your aggregate in, and then you have to deal with the fact that concrete's not a very forgiving material, and when you want to make it look pretty and everything. So what we've done is we've actually developed a unique material. So it's called a lightstone material. It's a thermoset composite that's most similar to corian.
Corian, if you don't know, and I didn't, is a material invented by DuPont in the late 60s. If you've been in a house, you've seen corian, used for countertops or sinks. And Wikipedia vaguely says it's used in many other items. It's non-porous, stain-resistant, seamless and repairable, both thermoformable and heat-resistant, and the color doesn't fade. For any chemists listening, DuPont's version is an acrylic polymer with alumina trihydrate. Pretty cool stuff.
But what we've done is we've taken that and figured out a way to 3D print it such that we can open up unique shapes like organic design, freeform, as well as having improved performance properties in terms of structural, thermal, air-water barrier, fire resistance, and having it such that it can still be milled with CNC heads that are used for copper and aluminum so that we can make it a really smooth stone-like finish. We can leave the raw print, which some people really like, or we can do things like make it look like brickwork or siding. And so to get back to your actual question, the answer is yes. So we can do individual components, like what we're doing currently with the ADUs we're delivering to the market already. Is there a hybrid? So they've got a 3D printed curved back wall combined with a traditional steel frame box. with our new Mighty House that was designed by EYRC Architects, and is the first deployment of our Mighty Kit system. Those ones are panel kit homes. So those actually arrive on site in shipping containers as 3D printed panels that then get stood up. And so it really, the goal at the end of the day is truly to be a design and product agnostic production as a service platform, and to really be a tool for industry to allow industry to do more. So our whole concept isn't that we want to disrupt the market by being everything to everyone. We want to disrupt the market through collaboration and focus on what we do well, which is the material, the printing technology, and the actual printing. And then partner with developers and builders who do what they do well, which is land acquisition, which is working with all the various subs that you need, even if you're still dealing with a 3D printed unit. Understanding the nuances of the local planning departments. Maybe it's their brother. Things like that.
Man, that's awesome. It's going to be hard for my questions because, this is a structural engineering podcast. And I think I really care I want to know more about this material, but also, I'm going to have to balance. There are a lot of difficulties that I know of when you're introducing a new system. Like we are looking at building codes and, local jurisdictions, especially here in California, you have to deal with seismic and all these connections and everything has to be tested. I don't really want to go down that road yet. I just material, like you said, it's kind of like sort of a stone product. Is it super heavy? Like what is its density of the stuff? Is it elastic? Like, is it most like concrete?
Yeah, so it's similar to it's effectively a synthetic stone, but doesn't incorporate silica. So we're not worried about some of the health issues associated with that. And so I think a good comparison is to look at our new fiber reinforced material that we're bringing online and compare that to a reinforced concrete. And so what we're able to do is print our material with a continuous fiber reinforcement, and that's going to open up moving into multi-story, which we're really excited about. And what that looks like in terms of material performance. Whereas a steel reinforced concrete is going to have a tensile strength of about 8. We're able to have a tensile strength of about 155 in terms of MPa.
Just to keep everything in check here, he's talking about concrete alone. If you aren't familiar with working with MPa, who is, grade 36 steel has a tensile yield strength around 250.
Yep. In terms of compressive strength, you're looking at about 50 for the concrete. For us, along the fiber, across the fibers is about 50. Along the fibers is almost 90.
Again, to keep units in check here, typical 4,000 PSI concrete, that's 28 MPa. Ultra high performance, very, very strong concrete, 10,000 PSI mix would get you to 70 MPa.
So we're much more high performance in terms of both tensile and compressive. And then in terms of flexural, we're up almost over a 180 in terms of flexural strength as well. And what that means in terms of density, though, is that we're about 4 times less in terms of weight than concrete. And in terms of thermal conductivity, 4 times better in terms of insulating. So it's a much lighter, much stronger, and much higher performance compared to a similar sized reinforced concrete beam.
Yeah. And when we think of concrete or stone, we're thinking about seismic. Brittle failure is a really big issue for a lot of the structures we look at. And when we're detailing out concrete, we have to put in special reinforcing to make sure we don't have some brittle crushing failure. Is that a concern with this type of system?
Yeah, so I mean, that's one of the reasons we're looking at where we've started with only a single story for our initial deployment, and then are going to be leveraging our new fiber reinforced material for moving into multi-story.
That's cool.
So we've really been moving incrementally. And part of that's both as we continue to improve the technology and the material, but also as we continue to go through the certification process and demonstrate that code compliance.
Yeah. How has, building code... How have municipalities sort of received the building from the building code standpoint? What sort of testing are you giving them, and generally have they been all right with it?
Yeah, so great question, and they have been. And part of it is how we approach them. We're not showing up one day just saying, "Hey, we're doing this thing." We're very good about engaging with planning departments and building officials pretty early on once we understand we have a unit there, and helping make sure they're comfortable. And the way we've done that is that we've been working very closely with UL, Underwriters Laboratories, as our third-party certifying agency. And the reason we chose UL instead of ICC or IAPMO or one of the other evaluation services that these days are a little more common in the construction industry is that not only does UL have over 100 years of experience in building life safety and doing this kind of work for the building code, they also have some of the world's leading experts in additive manufacturing. So they were uniquely situated to understand the technology and then see what does it mean to actually demonstrate that code compliance. So we went through a whole evaluation process with them. We have an evaluation report. And what was really cool, because no one else had ever evaluated this kind of technology, a light curing gel that comes out of a 3D printer for use in construction, they actually ended up creating a whole new standard, UL 3401, to outline the investigation of 3D printing in construction. And that's now been added as adoptable appendices to the 2021 International Residential Code.
Wow.
So we've been really doing a lot of work on the regulatory side. And along with UL, we're also working with ASTM. We're helping lead the subcommittee that's developing their new standards for 3D printing in construction, because we feel it's really, really, I mean, as you know, like, the building codes are written in blood. They exist because things went wrong and people died. And so it's incredibly important to us to make sure that we're doing everything we can to demonstrate the safety and the code compliance, as well as creating frameworks for evaluating 3D printing more broadly. Because if something goes wrong with another company's build, that doesn't just reflect poorly on them. That potentially sets back the entire technology by a decade or more. We can't afford that if we want to actually solve the housing crisis. So the other thing that we've done is, because we're doing this as prefab, because that makes it easier to ensure your quality, allows us to operate 24/7, so we don't have to worry about shutting down at night for noise ordinances, things like that. It means that we get to operate under California's factory-built housing program. So instead of needing to get a building permit from every local authority having jurisdiction, we actually get our permit from the state. So we work with the design approval agency that does all the code reviews. And so that's essentially your building official. And then the units themselves, because they can't be inspected on site without breaking into the walls and everything, because they're arriving fully manufactured, we actually have in-plant inspections by another third-party inspector certified by the state. So when we get to the local authorities, it's more about, we're really working with them for the foundation, the utilities, and the other site work, plus your planning check for zoning purposes.
Wow, man, way to go getting through IRC. I mean, that's a huge leap to get into the IRC coming up, just to smooth things in the future. That is really cool, and probably a big boost for the entire industry.
Yeah, and that's completely, and that's something we're really proud of, and that's something that, again, goes back to this idea of disruption through collaboration. Yeah. It's really about finding those right partners and finding the people in the space who believe in the vision and want to see it move forward. And so that's something we've been really proud of, and had reflected back to us from industry and regulators as something they really appreciate. Because we're not showing up like an Uber or someone saying, "Hey, we're doing this. We don't care." We show up and say, "Hey, this is what we're planning on doing. This is how we're thinking of doing it. This is how we're addressing what we think are your pain points. What are you seeing? What do you hear? What are we missing?" Yeah. So we've been really, really good about engaging with both industry and regulators to really understand their pain points, and to make it clear that they understand that our goal is trying to make their
lives easier, is what he was going to say. We had some audio trouble. Oh. Okay, so I have a question for you, and this probably applies to a lot of prefab sort of stuff, but I don't know how this works. Let's take, your first model. How is that designed for environmental loads? Is that like you look at the worst snow load in California and then take the worst, temperature gradient? Like, you can't cover everything. How does that work?
Yeah, great question. So we designed it to fit in 80% of all backyards in California. So we didn't look at we decided not to focus on areas like Truckee and elsewhere that have just crazy snow loads, because they'd be so over-engineered for the rest of the state. Mm-hmm. But what we did do is we took seismic very seriously, and it's been designed to withstand seismic loads everywhere except for one part in I think the San Pablo forest, which is apparently the worst spot to be in the state if a big one hits. But they're really solid. We've honestly over-engineered them for safety, taking into account the fact we are using novel materials and really making sure that we have safety buffers, just to make sure it's as easy as possible for a design approval agency to approve it.
Totally. Do you know, from a seismic standpoint, is it just a tested system, or does it conform with some existing system that we have?
Yeah, so the approvals thus far have been based primarily on using state-approved modeling software. Mm-hmm. And so it demonstrated running the material based on its material tested properties that are certified with UL, running that through the software and getting those calculations. But we're actually really excited to utilize some of the really large shake tables that the UC system has, particularly the one over at Richmond Station, because the one down in San Diego is undergoing, it's like a 3-year upgrade while they move it to a 6-axis table. But yeah, we are definitely excited to get some units on the shake table over Richmond Station and shake them potentially to the point of failure if we can.
Yeah, is that something in the books? Like we'll see in the future.
Yeah, it's something we're looking at. We've had some early discussions with the lab there. Part of it is waiting to get through this next certification process for our panel system, but we're definitely looking forward to getting some units on there, hopefully before the end of the year. But with COVID and everything, it got a little messy.
Yeah. Well, I'll be looking forward to like videos on your site or wherever that pops up. So one thing I think it's really cool with 3D printing is, the ability in the future for us to, as designers, think of a concept, analyze it, and basically just hit print. Is that something that we could see in the future with Mighty Buildings, where we know the structural characteristics and we could just send you, here's what I need, let's do it?
Yeah, and in fact, our software team's actually already developed a Revit library to make it easy to use our panel system. And that's kind of going to be the groundwork for continuing to build that out, such that you can take a design, you can design directly with our technology, with it calculating those loads, calculating the costs. And then we've got a whole software suite that automatically takes those 3D models and converts them into printable files.
That is freaking sick. Man, okay. You guys are on it.
Well, and we're also using, we're excited. We're leveraging simulation software to be able to reduce new product introduction timelines and costs. Yeah. So we can simulate a build thousands of times to catch any design flaws or any potential quality control issues or production bottlenecks, and address that all before we ever get to that first real build. So there's a lot of, in a lot of ways, what we're doing is we're leveraging 3D printing and robotics to allow prefab to truly become Industry 4.0.
So let's talk about cost real quick. What is sort of the cost of one of these finished units, maybe in $1 per square foot or a comparison? And, does that cost, housing in California is expensive. Housing in Illinois is a little less. Is there some scaling, or as you build, will the cost decrease, do you think?
Yeah. So right now, the units we're delivering are about 40% less than comparable quality stick built, because we are building type 2 semi-luxury. And delivering it much more for a standard or moderate price. And so that's one of the big advantages we have, along with the time savings. And that's a great point about California costs. And so our vision long-term isn't to export from Oakland to the rest of the country. Yeah. Our vision is a distributed production network using what we call mighty factories. So the cool thing is, because we're using 3D printing and robotics, we can set up in a pretty small footprint. Our facility in Oakland is an old Pete's Coffee warehouse. 79,000 square feet, of which only 50,000 is production floor. At our initial stage of industrialization, we're targeting to be able to generate 300,000 square feet of production out of that 50,000 square feet of floor. And in our stage 2, we're looking to increase that to 1.2 million square feet. So the idea is that we want to set up mighty factories in areas where we have demand, so we're not creating jobs for those markets, as well as providing housing for those markets, and that we're not exporting the high cost of labor and everything from California, so that we're taking advantage of the differences in the cost structures in those locations to really make sure that we're optimizing it. But even without that, even producing here in Oakland, with our new panel system, we're targeting to be down closer to $100 per square foot.
Wow, that's very competitive then. To give you a little cost comparison there, the average home in the U.S. in 2019, so before things went wild, is 2,594 square feet. And that's built at an average cost of $114 a square foot.
Yeah, cool. We're not looking at just being here in California. Right, we've always had a vision of being a global company. Mm-hmm. So we're already in conversation with developers in other parts of the U.S. as well as other parts of the world for the potential deployment of another factory, hopefully within the next 2 years.
Man, what is the time from start of a project to project? Let's say, what is the printing time, and then what is the total build out? You can get it on site.
So once entitlements are in hand, because obviously that's the permits are always the big wild card, even with ADUs and the streamlined permitting process. We're able to go from a blank slate to a completely delivered unit and finished in less than a month.
Wow.
And so I think we're producing 2 to 3 units a week. Out of our facility is what we're able to produce out of the facility. And then often we're doing that in parallel to while the site work's happening. Mm-hmm. Because again, joys of prefab. And so we're able, for a fully printed shell, we can do a 350 square foot shell, not in a day. So we can have that fully done and kitted out and finished in less than a week.
That is wild. Okay, so sustainability. I know you come from sort of a sustainability background. Can you just speak on energy efficiency of the Mighty Building buildings and the material themselves? Like, what is that process like?
Yeah. So we've designed our units from the beginning, and that's part of why we're in California, is how stringent the building code is, particularly in terms of energy efficiency. And because if we can build here, we can build anywhere.
Yeah.
And so we've actually even looked beyond Title 24 and actually been looking at Passive House as kind of our guiding light in terms of energy efficiency. So no, we haven't certified any of our units to Passive House, but my understanding is that a couple of the units we've delivered in Southern California, based on their orientations and everything, would in fact qualify. Mm-hmm. And so right now with our panel systems, we're looking at an R value of 25 for a 6-inch wall, which is pretty good. We're looking at ways to further improve that. Mm-hmm. And obviously in the near term, we can just make the walls thicker and things like that in order to accommodate more extreme climate zones. So from that perspective, when you combine that energy efficiency with the cost effectiveness of what we're doing, we're actually going to be able to deliver true zero net energy homes without breaking the bank. Because obviously that's one of the reasons California stopped short of requiring true zero net energy is the cost effectiveness test required, and the fact that battery costs are still a bit high, or still too high to actually mandate it. Zero net energy is a big part of it, the fact being getting ahead of the building codes. And on top of that, we're also able to produce our units with effectively zero waste, because we're printing only what's needed. So we're helping eliminate the 3 to 5 pounds per square foot that goes through landfill in a traditional build. So that's a couple tons of carbon per unit, which is huge. And then that's one of the other things, is that we're actually working with the regulatory space again to try and improve how those sustainability impacts are reported in terms of environmental product declarations and life cycle assessments. And then the material itself, we've actively developed a formulation that reduces the carbon footprint, and we're on track to achieve our commitment to being carbon neutral by 2028. And a large part of that will be dematerialization, so reducing the amount of material required by improving the strength and other properties, while also bringing in more biologically derived inputs as well as recycled material.
What is the team that you guys have at Mighty? Like, I imagine it must be chemists and structural engineers and computer programmers, and is it just a whole mess, a whole university in there?
Basically, we've got an amazing team of engineers, structural, civil, mechanical, architects, various types of designers, software programmers. It runs the whole gamut. And then we also have our whole sales team and our compliance team, and so and our sustainability team. It's pretty amazing. The eclectic nature of the backgrounds that kind of have a lot, but some incredible material scientists. That's our cool. And our CTO, my co-founder Dimitri, him and the team on the material side have just done an amazing job of introducing a game changer.
That is really cool. One question Zach and I were talking about beforehand that I didn't get to put in. One of the issues with generally 3D printed structures is the adhesion between the bonds. Oh gosh, sorry, that's not what I mean. The adhesion between the layers.
Yep.
How has that worked for you?
Well, if you're dealing with something like concrete that has mechanical adhesion, then that's totally going to be an issue. We're not. We have full chemical cohesion between our layers and end up with a monolithic shell.
I'm really jumping around now, but I wanted to get back on insulation. Is it just that the material has insulating qualities, or do you actually put in a cavity and then fill that with some foam or something like it?
So both, yeah. So the material itself is about 4 times more insulating than concrete, but we also leverage the empty cell space inside and use PU foam that we're able to automate the pouring of into the interior structure.
Yeah, that's cool. And then foundation design, that is by a local engineer or something?
Yeah, so for the units we're delivering now, we have pre-designed about 7 different foundation systems for it to accommodate the various needs of specific sites. So I think most, if not all, the ones we've delivered so far have just been slab on grades, but we've designed them for skirts, helical piers, concrete piers, like all various needs. Again, all depending on the site.
Yeah,
but it's pretty robust, so it does well.
Oh, that is so cool. Okay, I have a couple questions at the end here that are more architectural than the last ones. I think we've actually hit it quite a few of them, but I just want to make sure I cover them. First one is sound transmission. So, being kind of low density and stiff, I might expect sound to travel through that pretty well. But you've got insulation. Is that an issue at all?
It is not. I don't have the acoustic rating numbers off the top of my head, but I know that we do quite well and that we have not had any complaints from any of the customers so far about it. So
Cool.
And in our own testing, it hasn't been a problem. So.
Yeah. How about fire? How does it stand up to, and does it have a fire rating of any sort?
So we've got a Class A flame spread rating on it. It has a smoke development index of 10 and a fire development flame spread index of 5. Mm-hmm. We haven't done certified fire rating yet. Our internal testing indicates that we should be able to achieve a 1 hour and could potentially achieve a 2 hour fire rating on it.
That's fantastic. So that 1 hour will get you to light commercial and plenty of residential. So
yeah. Exactly.
Cool.
And that's that's been something we've designed it for. Like that, that's been a part of the formula development, has been with an eye towards the fire performance.
Okay. How does the material perform as a building envelope? Like generally we have house wrap and a million layers that hopefully work well enough, but this is just one uniform.
Yeah, it's hydrophobic. It's naturally antimicrobial. So, I mean, one of the things that I'm really excited about and where we're moving towards is really the ability to use our panels and our material as everything, as your fire barrier, air barrier, water barrier, thermal barrier, vapor barrier, and your interior and exterior finishes, basically all in one. So that's really where we're going to. And part of that's just continuing to build out the certification that we have. We've already certified the units we're delivering currently for air tightness and everything. Mm-hmm. And then we're in the process of moving forward with that with our new panel system as well.
What about modifications in the future? Let's say you just wanted to attach to this, drill a hole, put in a door out to a little canopy. What would that look like? Would that be going through you guys to, make sure that the remaining structure is adequate or reinforcement?
Yeah. So obviously by law, any unit delivering has to be able to be renovated and fixed and everything. So it's definitely doable. And you can do it with standard tools and everything. And our material works well with traditional materials. That's actually something we've demonstrated with our first units that are hybrid, 3D printed and traditional. I would encourage people to check with us before doing it, just to make sure. In theory, there's nothing that would stop any GC from going to town and doing what they need to do.
Yeah, so you can cut it with a normal saw. It's not like
and we've got repair kits that we've developed, but it can also be fixed using just sealants so off the shelf from Home Depot or Lowe's or something.
Since you mentioned repair, a little bit ago, a branch almost wrecked my roof. If this was a Mighty Building house and it kind of cracked the wall, what is a repair like? Is it bring it up to the original strength?
Yeah, so we've done extensive testing. And one of the cool things again is that because we're using light to cure, that system can be downscaled. So we have the ability to put material in and then hit with a UV lamp, and it returns it to a monolithic form. So it's actually we are in talks with the city of San Francisco about potentially doing some hardscaping. And so one of the things to even be considered was that we had to we had to let their maintenance team go to town on it. Mm-hmm. And that was honestly has been one of the highlights of the pre-pandemic was taking this big piece of a bench over to the maintenance yard in Golden Gate Park and letting their team go at it with sledgehammers and saws and everything, and then showing them how to fix it. Like they loved it. So like the durability and the repairability is definitely pretty impressive.
That is so cool.
Is there a main piece of technology or something you guys are developing to make this bigger, quicker, more mainstream? What's the next piece that is in the puzzle here?
So what I'm most excited about, I mean, we've got a lot in the works, but is this new fiber reinforced version of the material that's really going to unlock that ability to move into low-rise multifamily and really address that urban infill density.
Okay. Could you kind of explain to us maybe trying to put in words how you would visualize the system is built in your factory?
Well, the easiest way is to go to mightybuildings.com or check out our YouTube channel where we have some videos of the printers in action. So that's going to be the easiest way. But what it actually looks like, so the printer itself is, according to UL, the world's largest light-based printing system. And so it's a big gantry-based printer with a printing head that incorporates lighting modules onto the nozzle, as well as the ability to deploy continuous fiber. So that's also one of the core IP aspects of what we're doing. And so that's where it starts. And that printer is about 11 feet by 13 feet by 26 feet. So we're actually limited by over-road transport more than we are by the actual print volume. And then it goes from the printer into our robotic finishing cell, where we have robotic arms that have been proven out in the automotive and other industries that then we use to do 3D scanning of the printed objects for quality control, as well as to create a digital model. And then we're able to swap the heads on that to use CNC milling heads in order to do surface treatment. Then we pour the foam insulation, and then in the future, we're also going to have the ability to spray stucco and paints and primers as well automatically through that robotic finishing cell.
Wow. Dang it. So that's a lot more involved than the 3D printer I have at my house.
Probably a little bit. It depends what kind of post-processing setup you have.
You got 2 nozzles, don't you, Zach? You could do,
Oh, you got a multi-jet. I like it.
Well, I just have a printer that has a couple of different size nozzles I can place.
Okay,
nothing
gotcha.
nothing fancy, unfortunately. I guess, Sam, is there anything else you'd like to add about what you guys are doing? Anything that maybe we haven't asked the question that you think we've maybe missed?
So just some of the key numbers. One of the things that we're doing, as I mentioned, we're able to deliver our units for about 40% less than comparable quality. We're able to reduce labor hours by about 90%. But at the end of the day, we're actually creating more work by increasing throughput by as much as 20 times. Mm-hmm. So that's one of the things that I'm really, really excited about is is bringing this technology to bear to get all the housing out there that we need to ensure that not only do people have housing, but that they have housing they can believe in, that they can love. Because that's something we really believe in. And that's also why we've started by focusing on the missing middle rather than going to affordable housing, is that the missing middle is this whole segment of the housing market that doesn't qualify for subsidized housing, but still has trouble affording to live in our communities. I mean, these are teachers, our firefighters, people who serve our communities, but more and more can't actually live in them. And so we think it's really, really important to be developing a solution that really works for them. And then once that's in place, that allows that we can go up market, we can go down market, and really address the needs of other sectors as well.
Well, we were talking at the end, Sam brought up that they are hiring. So if you're interested in doing some crazy work, check their website out.
We got a whole host of roles. People can find out more at careers.mightybuildings.com. Really, really exciting team to be a part of. And yeah, would love to have some of your viewers throw the names in the hat.
Cool. Where are you guys based out of again?
Oakland.
All right. Thank you so much for all the information. Yeah, we really appreciate having you on the show. And
I really appreciate you guys inviting us. Like this is really fun. And yeah, sorry. In retrospect, maybe I should have brought one of my engineers too. But hopefully I did a good enough job of covering those details for you.
That's it for our interview with Sam at Mighty Buildings. We really hope you enjoyed. If you have any questions or comments, as always, feel free to reach out.